Hello,
Yeah.
hello. Am I audible?
Yes.
Yes.
Great. Just got off meeting. So yeah, let me share my screen first.
Yes.
Uh,
Please go ahead.
because uh, because I have been working around LLMs like as soon as they were launched, like from 2022, I've been working with them. So is my screen visible to you guys? I hope. Yeah, it is. Okay. So hello everyone. I'm Jay. I'll introduce myself on what I do and how I do shortly. But first, let's deep dive into topic what I have chosen. So every now and then, you all guys have a similar questions that how can we connect our data to LLM? Like what to do if my data is not trained? And sometimes even your corporates don't want their data to be trained on LLMs. At that moment, what to do, right? So what we do is we use a algorithm named as a technique basically, which is RAG called retrieval augmented generation, in which we store our private data in our private databases, and then and only we give the data to LLM which it requires, not everything. So that's just a gist of what we are going to do, but we'll go deep down. Don't worry about it. I have written some interesting code for you so that you can see for yourself as well. So who am I? I am a research scientist. I work with LLMs. I do a lot of stuffs with LLM, much more of benchmarking, testing them across many different use cases. So I work around with them. I'm also a research intern at Symbiosis. It's in India. It's in Pune, India. I am organizer at TFUG Surat as well, and I have published three of my papers. Third one is on specifically on generative AI and benchmarking. So first of all, what is Gemma? So Gemma is like a smaller version of Gemini that Karthikeya mentioned as well. That Gemma is a smaller version of Gemini. Now, why Gemma is required? That we sometimes want to run inferences on our local host instead of sending an API request to a server. So that's why Gemma was invented, and it is Latin from for precious stone. That's how the name Gemma is came into picture. And Gemma has the same model architecture, same research, and same technology used as in Gemini models. So whatever Gemini can do, Gemma can do as well. Now, for very all of us will have one question in common, that why to use Gemma if we can say send a simple API request to Gemini via Google AI Studio or Vertex AI. One of the reason is that it has the same model architecture. Second, you can run it on your local servers. So you don't need to have an dedicated inference hosted on your clouds. So it will save you a lot of cost. First, second, it is smaller in size, so you can like test it whenever you want. And third and foremost, and the one which we all need is a data is not used for training. So anything you do with Gemma, it would be on your local computer and it would be running with you only. So your data is not going anywhere. So another question that we all have, that what Gemma models are available. So there are two variants that we have. Is one is 2 billion, second one is 7 billion. There are instruct model for Gemma as well, which we will be using Gemma 7B instruct. We will be using Gemma 1.1, the latest one which has came. And while instruct is a better model when it comes to have a question answer system or chatbot, because it understands context more properly rather than Gemma 2B or 7B. Gemma 2B and 7B are general purpose models. They can be used for hyper tuning for your personal use case. Instruct models are one which you can use without hyper tuning it, and you can just use on the go as you are using Gemini. While this does not mean that normal models does not follows the prompt, they do, but they are not as good as instruct models when it comes to question answer. So let's go to some interesting part. So just in case if anyone wants to follow me what I'm doing, you can go onto this link. You will be redirected to a GitHub page, and just go there and open up the notebook in your local computer. I can explain you as I go. Let me know when you are done. And feel free to ask questions. Feel free to stop me. I don't mind that. Okay, okay. Yeah. Have a look. You can scan QR code as well, or you can take a screenshot of the screen as well if you want to follow it up in future.
Yeah. Yeah.
Okay. Yeah. Okay. So this is collab. This is connected to my GitHub. So I can do everything here. You can do same as well. So first line, we are installing LangChain. We are using ChromaDB for our vector database. We are using PyPTF for extraction of text and sentence transformer for converting into embeddings. Now, what are embeddings? Embeddings are vector representations of the sentences that you use. Why it is required? Computers does not understand hello world or hi how are you. They understand numbers. They understand vectors. That's why we need to give them vectors to understand and predict the next vector, and then we remap it to what we want. So this is we are importing text splitters and token splitters. This is our ChromaDB. ChromaDB will be used for vector embeddings and embedding functions. We are going to use all mini LMV2. It's a transformer model which will be converting our text to embeddings. This is PDF reader. This will be used to extract our PDF. This is request to send a request to Hugging Face API. This is I guess Victor asked this question that if we don't want to use our uh, API keys, then what to do? So what you can do is just create an environment variable like this in Colab, and if you are using your local computer, create a .env file. There is a Python package named python.env as well. You keep your all the API keys and environment variables in .env file, and you can import it like I have imported it here with a variable name you want, and wherever that environment variable needs to go, it can go there. So HF barrier is going here. So instead of user data.get, in your case in local computer, it will coming os.get.env. So it will take your env environment variables or API key from there, and wherever it needs to pass, you can pass it. Like I have passed it here. And this is example PDF. That's an alphabet report for 2023. I just downloaded the random PDF online. So we are going to extract text from this PDF. This is extracting text in list format. This is a list comprehension. This is extracting text into this kind of stuff. So it will extract text, and after that it will be a list. So if you remove 0, it will be entire list. So this way, this would be a long list. That's why I kept 0. So we will be seeing only first part of this list. This will, after that, we separate it into, like, there is, every time there is a line, there is a double line, we separate it from there, and we remove unwanted stuff. Here there is no bullet. Otherwise, if there was a bullet, it would be going there. It would be removed when it comes, when this is executed. And after that, this will separate them into words. Then we again join this, and that's how it is working. So whatever this will return, and this will get joined. And after that, you can see that our first here and first there, you can see what there is a huge difference. So PDF text 0 is this, and our current text is this. So you can see um, how much stop words and everything has removed. You can see. Oh man. So you can see how much stop words and everything is going away. After that, we tokenize them. So this token, Just a second. Yeah. So this will be converted into tokens. So this is still a sentence. After this is converted into token, and you can see if this you can see that how it is now. So alphabet announces. So you see this A, F, Q, everything is converted into small, and all if there is an ing or liking or like they would be converted into tokens. So all the unwanted data which we do not want to send it to LLM will be removed in this case. There are two reasons of doing this. First, we will save cost in this case. Second, is R and all they will not change the direction of our vectors. That's why we do this, and that's why this is important to do this. So current token size is over 256. So this will have approximately 256 tokens. Now we are going to embed them. So we are initializing our embedding function, what embedding it is. Then we are initializing our ChromaDB client. After that, we are creating a collection. I have created an alphabet annual report. You can keep any name here with respect to what you want to name. And embedding function would be what we are creating. So if you change a variable name here, change variable name here as well. And then we create our vectors. So after that, it will have 40 IDs because our chunks are 32. So chunks are 40, actually 40. There should be 40 chunks. That's why there are 40 IDs here. Here are 32. And if I remove this line, you can see, yeah, see, there are 40 chunks. Here are 32, but after we tokenize them, there are 40 chunks. That's why there will be 40 chunks inserted to our database. And as soon as we insert it into it, it would be converted into embedding and then we can count them. And this is our RAG query. RAG query is basically what we will send to prompt to first our vector database, what to search for, and whatever it will search, it will return it in retrieved documents. Like this is retrieved documents, and we will be combining the entire retrieved documents with two lines in between, and then we send it to LLM. That is what this is doing. So let's see. This is my query. What are cloud services? So first I will send it into query, that what would be my query, and I am asking maximum results would be 1. So whatever is the closest thing here to 1, closest thing here to query would be sent to us. That's why because we have selected 1, it would return only 1. So that's how it will work, and it will be returned under a dictionary, and dictionary will have a key name document, and on that 0th index you can see the text. So it would be having this kind of text information. Google Cloud includes infrastructure and platform services, collaboration, and other enterprise customer. GCP generates blah and blah. This is what this here it is. And then we send it to our LLM, this RAG. So our query is this, and our retrieve document is this. This will get joined. This will go to Gemma model, and after that we are sending it to our Hugging Face API request. It will return an output, which is this. Cloud services are not explicitly defined in given text, so I am unable to provide an answer from the provided content. Now, so this means that there is no mention of cloud services. There is mention of something else. So let's see if it is true or not. Multiple operate that are not individually revenues from other parts and healthcare. So see, there is no mention of cloud services. That's why. So if you want to ask any question, just comment it on text box. So I can just show it there, and we can see.
Nobody has
Okay.
a question.
Thank you very much.
Yeah, so Jay, thank you very much for your presentation.
Oh, I thought someone will have questions, but
Yeah,
okay, no
yeah.
worries.
Thank you very much. So, thank you very much. If anyone have a question about this event, please you can ask. No questions? Yes,
Go ahead, Victor.
Victor Asuko, please go ahead. Mhm.
Uh, Good evening, everybody. Like, I'm super excited to be here to connect with everybody, starting from the first session to the one we had last. I mean, the sessions were really impactful. So, my name is Victor Jacob Ashuko. I'm passionate about generative AI, large language models, and Google AI. And seriously, I'm very fortunate to be in this meeting to meet Louis, Japheth, Amel, Jay, Katisi, GDG, Abidjan, DGG Cloud, and every other single person here. So me myself, alongside with other passionate TensorFlow or people interested in generative AI, we started a group in our local community, and I've been trying out to reach out to Amel and every other single, or let me say every other GDG TensorFlow, yeah, TensorFlow user groups out there. So I want to share this opportunity with everybody that we are starting a TensorFlow user group in Uyo in Nigeria, and we would like to connect with every single person as well as other TensorFlow user groups across the world. Okay, so I would like to reach out to I'm a TensorFlow lead Abidja after now.
Okay, okay. I dropped my email address in the chat. You can write me after. You can change. You change.
Uh,
That's right.
Thank you very. So yeah, thank you. Okay, thank you.
Okay, okay. Feel free to ask me any question. You can help you.
Okay, I will.
Yeah, thank you, Victor.
I think some. Okay, okay, okay. Wait, wait. Jay, I already give you a answer for that.
Sorry, Armin, I didn't got you. Can you please repeat?
I say that I want to say Victor asked a question and you are already give a answer.
Ah, okay.
Yeah.